So now I will be discussing the bubble sort. Let's go over there. Let's run the program that I made. Then let's input the choice 1, another choice 1 for bubble sort. Enter pipe value. And then the value we're gonna enter is this, is pipe. So first is 56, 23, 34, 89, and 12. Then it's gonna sort that, and it's gonna become 12, 23, and the final output should be the same, which is 12, 23, 34, 56, and 89. So good. So now I will be explaining how does it work, the sorting. It's this. And so first starter is this loop is for inputting the number, and this loop is for displaying the sorted number, and this is for the bubble sorting. So I will be explaining it now. So as we can see here, I made a graph here, a chart, so we can follow the loopings. So first is 0, 5, so I for I here, and then 5 J4. So 0, so the first value for I is 0. Yes, so 0 is less than 5 since true. The program should run, and then let's go then we're going for another loop, 0, and the condition is 0 is less than 4. If 0 is less than 4, and then it should be true, and we're going to the statement, if statement. So if statement is asking if a value of j means a0, which is this, and then its position should be here. This should be our a value of j, and if a value of j is greater than a value of j plus 1, then it's gonna be a value of 1 should be here, number 23. So that means if a value of j is greater than a value of j plus 1, since greater, yes, we're proceeding to swapping. We're gonna swap 56 and 23, which is what's gonna happen here is that first the value of the value of the value of aj plus 1 should be j should be put in this last number, which is ln, and then the value of j plus 1 will become the value of array value of j, and then the array value of j should be should get the last number, which is 23. So if we put that here, so rln will become 23, then r our arr j plus 1 will become 23. I will become 56. And then, since here it should be ARRJ will become 23, which is the value of our last number here. There. If we go back here, then we can see here the swap. We swap these two, and then we're gonna add another one here. Since j plus plus, so we'll increase the value of j. Then we'll go to another loop of j. Since we're not finished with the loop of j, we won't be going to the loop of I. And then we'll go in here with which is 1 is less than 4, true. And then if value of j, since the value of our j now is 1, so our our array will be stepping 1 ahead here, which is here. So if j plus 1, since our last swap is here, we'll be using this pattern. And then if j plus 1, since we are 1, we'll use this, and then check if if our number 2, which is in j, which is our j plus 1 is equals to 2, we'll check here if j is greater than 34. So since yes, we're gonna swap 56 and 34, which is we can see here. Then we're going to the next, and then we are going to the next loop, just 2 here, and here. So the pattern should be here. This is our last. So since we see this, that if j, which is our 56 now, is greater than 89, since the statement, since the condition is no, we won't be doing the statement here, and we'll proceed to 3 to increment the value of j. Going to 3, and then since it's still not 4, this is our last loop. But we'll be doing that. So 3, 4, 3 is less than 4, yes. Then we're gonna swap 89 and 12. Since the value of 89 is greater than 12, so we're gonna swap that. Then 4. Since 4 is less than 4, I'm not gonna put that here. Just gonna put that next. Since 4 is less than 4 is no. So we're done with the first loop of j, and then we're going back to the loop of I. And then we'll increase the value of I, turn into 1, then 1, then 1 is less than equal to is less than 5, so 0. So since yes, we'll be doing that here, and then same as before here, less than, and then the condition. So our condition is 0 if our 0 is less than, if our 0 is greater than, which is or is our last swap. And then this is our last pattern. This is our last pattern. Let's copy this, put this here. So this is our last pattern. And then our first is no, since 23 is less than 34. So next, look, increase the value of j and then 1 and n. So if 34 is greater than 56, then it's still a no. So we'll increase the value of j and then return to 2, which is our 56. Then here, then condition, if 56 is greater than 12, here, and then yes, since 56 is greater than, yes, we're going to show 56 and 12. And then, yes, 56 and 12. So you can see that. So we're making this 12 and this 56. And then we'll increase the value. And then since 3 is less than 4. And then let's check the value for 56. If 56 is greater than 89, since no, then the value should be increased to 4. And since the 4 is the last, then we're going back to the I here. Then 2 is less than 5 and 0. Then we'll go back to the J and start again. So the value of our J should turn back to 0, and then 0 is less than 4. So we'll go back to the start again. If 23 is greater than 24, since no, then we'll increase the value to 1. We'll increase the value of j into the 1. We're not performing this. So j, and then yes. So if j1 is greater than j1. So since yes, 34 is greater than 12, this is the a, aj, a value of j, and this is the a value of j plus 1. So since 34 is greater than 12, we're gonna solve 34 and 12. Then we'll increase the value of j. So there should be 12 and 34. Okay, and then we'll proceed to the next number, 2, which is 34, R34 again, and then 2, 4. Since 34 is not greater than 56, we'll not be doing that. And we'll increase again the value of j. And let's go to the third and go to the 3. Since 56 is, again is not greater than 89, so we'll be doing that again, increasing the value of j. And then since that's the last, so the last of j, then we'll increase the value of I now. Then we'll go back to the 3. So we'll go back to the I and then 3, which is its value now. 3 is greater than 5. Since true, we'll perform this and we'll turn back j into 0. So 0 is less than 4. So we're gonna see this, and then if 0 is less than 0 plus 1, so that should be it. Since yes, we're gonna swap 23 and 12, so position should be here and 23, uh, and then increase the value. But as you can see now is the value, as you can see now is that it is already sorted. See, since lowest to highest. We can see here that 12, 23, 34, 56, and 89 is in order. And but since the program is still not done yet, it's still gonna continue to processes this part, even if there is no swapping that's gonna happen since the swapping is already done. Then that should be the answer. Let's run again and check. Let's run it again to check it. And then here. So our choice, let's choose one and one for bubble sorting and enter the value 56, 23, 34, 89, and 12. So as we can see here, their places is correct. So 12, 23, 34, 56, and 89. 12, 23, 34, 56, and 89. So that's it. That's it for bubble sorting. So now I will be explaining the selections. So first, let's run the program for selection sort. It's choice 1 and choice 2. So we assume the value here is 48, 32, 65, 45, and 10. So the value here that we see here is similar to this. Then now I will be discussing. So how did we get this? Okay, so going into this now. So this is the syntax for bubble sort. Bubble sort, no, selection sort. The syntax for selection sort. So I made this chart for this. So we're gonna remove this now so that we can change it later. So we're gonna track track the selection that is happening, the sortation that is happening. So 48, 32, 65, 32, then 65, 45, and 10. Hmm. So now that we have it, let's try it. So the value of RZ should be 0 now. So it's 0. And then 0 is less than 5. Okay. Then the value of me should be now value of Z 0. This should be the 8, 48, which is value of 0 is here. This is the array. This is the array. And then the value of 0 in array that we have now is 48. So we see that the value of prime should be 48. And now the value of r should be equivalent to the value of z. And then it should be 0. So now we're going to the condition. Okay, and then is 0 less than 5 is then yes. Then go to the condition that if I is less than mean 0, which is 48, is less than 48 is now it's a no. So we're not doing this. So we're not doing the swapping. That we're not changing the mean. So then we're increasing the value of I, then it's gonna be 1, then 1, still less than 1, less than 5. So if our noun value of I is equivalent to 1 is gonna be 32, then yes, we're gonna swap it. Then first we'll change First, we'll change the value here. We'll get the value of num_i and put it in the min for the swapping that we're gonna make here. And then it's gonna be 32. Then we're gonna swap, and then we're gonna swap the num_i and num_j. So num_i now should be the value of num_j, num value of j, and then our num_j should be the value of min. So we swap it, and then so the value of the values in our array should be swapped. It's gonna be 32 and 48. Then after swapping that, we'll increase the value of I, and then we're going back to the loop again since 2 is still less than 5. We're running the condition here and another condition if num, but since 32 is not less, since 2 and 65 is not less than 32, we're not doing the swapping. And then same as here, 3, which is 45 is not less than 32, still doing the swapping. We're still not doing the swapping, and then we're going 4, which is 10. Our num value of I is equivalent to 10. So that means we're gonna put 10 in the min for our swapping, and then we're gonna swap 10 and 32 here, just like I said earlier. We're gonna put the number we're gonna put the number we're gonna put the number 32 in num_j. We're gonna put the number num_j, value of j, which is 32, into the value of num_i, which is 10 here, 4. So we're swapping the 32 and 10, 0 and 4. So that means their places should be 10 here and 32 here. And then we're increasing the value again of I, and then since our I now is already 5, we are terminating the loop of I, and we're increasing the value of z. Then we're going to the z again. Then since 1 is less than 5, then we're still going, and now we're in the array of 1, which is 48. Our min now should be 48. Since num_j, which is num value of j, is 1, and our array value is 48, 48 should be given to min. So now we're going here. So now our value of I should be the same value as j, and then it's gonna be j, and then it's gonna be 1 is less than 5, but since 48 and 48 is not less than on each other, we're not doing that. We're not doing the swapping, and then we're increasing the value of I, and then we're going to 2, then it's gonna be 2, and then 2 is less than 5, yes, and then if num_i 48, 8, no, 65 is less than 48 is still no. So we're skipping that part, then increasing the value again of I, again the loop, and then again the loop with a value of 3 now. So it should be, the statement here indicates that num array 3, but num value of I, which is 3, array 3, is 45 is less than 48. Yes, since yes, we're putting the 45 in the mean, and then we're swapping 45 and 48. 45 here, and this one is gonna be our 48. After swapping that, we go, and then we're going again, then we're increasing the value I, which is gonna be 4 now. 4 4 less than 5, yes. And then if num I is less than 30, is less than mean. So since 32 is less than 45, we're swapping it. We're putting 32 in our mean, and then we're gonna swap 32 and 45 and increasing the value of I. So we're gonna 32 and 45. So now the value of R should be 0, 10, 1, 32, 2, 65, 3, 48, and 4, 45. So we're still continuing this and then increasing the value of I, since 5 is less than 5 is no, we're terminating the loop in the I, and then we're increasing the value of Z. And 2, now the value of Z is 2, and then 2 is less than 5, yes. And our and the value of our and the value of our num value of Z, which is 2, so we're going to the array 2, which is 65. We're going that and put it in mean, and then we're going to, since always the first part of this loop is gonna be the same, that it will be 65. If 65 is less than 65 is no, so we're not doing the swapping, and then 3, then we're gonna ask here, and then it's gonna become is 48 after increasing the value of I. Well, we're moving here, uh, we're moving here to 3, and then 3 less than value, less than 5, and then if num value of I is equals to 3, and then our array is 3, 48 is, and then our, since our mean now is 48, so if num I, which is, if our num if our num I if our num I is less than our mean, which is 48, and then I forgot to change it, we already swapped 48 and 65, and then we're going back here, since if numpy, since is num value of I is equals to 4 is less than num is less than our mean, which is our 48, then we're gonna swap it 48 and 45. This is gonna be the 45, and this will gonna be the 48. After swapping that, we're increasing the value of I, and it's now gonna be 5. Then we're moving along, we're increasing the value of Z, and then we're going to, and it's gonna be 3. So 3, so the value of Z now is 3, and then 3 is less than 5, still true. So so num value of Z and the value of RZ is 3, and then our array, the value of array 3 is 65. 6, so our mean is gonna be 65. then since this will gonna be 65 if num I num value of I is equals to 3, then 65, then it's gonna be 65 is less than 65 is no, so we're not doing the swapping. Increasing the value of I, and then it's gonna be 4, and then now that it's 4 is 4 less than 5, yes, and then we're gonna ask if num value of I is equals to 4, equivalent to 4, array 4 here, and then it's gonna be 48, and then since it's less than 65, which is our mean, we're gonna swap 48 and 65 here, then 48 and 65, then that increase the value of 5, increasing the value of 5, okay, and then terminating the program because 5 is not less than 5, then increasing the value of z, it's gonna be 4, and then 4, then 4, then the value of rj is 4, and then condition 4 is less than 5, then our main is now gonna be 65. Now our main is gonna be 65, and then 4, same value as z. Our the value of our I is gonna be the same value as z, and 4 is less than 5, and if now, so it's gonna be if 65 is less than 65, no, so when I'm doing swapping, increasing the value of I into 5, then terminating the loop of I because 5 is not less than 5, and then also increasing the value of z, terminating the z, and then terminating the z because 5 is not less than 5, and then now the the position of our array should be correct now, which is 10, 32, 45, 48, and 65. So the let's see the program that we run. It should be 10, 32, 45, 48, and 65. That's it. So now what I'm gonna discuss now is the binary tree. So let's go. So let's run the program again. Then pick the choice number 2 for binary tree to person traversal. Pick 5 number. So, so what I'm gonna pick is usually 10, 15, 20, 25, and 30. So the orders that we get is, let's check this first is 3, then we're gonna see the pre-order 10, 15, 20, 30, and 20. So, so first, let's see this here. This. So this is the placing the ticket. So let's check the pre-order. So let's check the pre-order if it's right. Is so for pre-order it's root, right root, root, left, and right. So then let's go for root. Now see this is the root. Check, and then we go there's left, root, left, and then left. Then after we go left, we see that here that it has a left and right, so that means this is also a root. So that will become 15, the root. So then it's checked. And we're going right, which hey, we're going left, which is the pattern of root left right. So left, check, and then right, 30, check. And after this set here, going back to the first row, and then we're checking the right, and then since it's 20, check. Then we're going now in order. For in order, our pattern is left, root, right. So since we're checking it now, so first check. So we're going left. After going left, since it's still a root that it has left and right, we're going left again. Then after that, we're putting the root here, and we're putting the left. Okay, first left 25, root 15. Okay, and then right 30. Okay, and then we're going upwards into the root 10. Okay, and then right again 20. Okay, and now for post order, our pattern should be left, right, root. So let's check it first. So the first row, and then second row 15. Then let's check left. Then since it still have left and right, left 25. Okay, left, the pattern left, and then right 30, and then root 15. Okay, and then going upwards is since 10 since 10 is a root, and by doing the pattern is this set is left, then this 20 is right. Okay, that's correct. And then the last one is root or 10. Okay, correct. Now we're going to the program. So here we see here that we have a that our first encounter should be we're getting the 5 numbers, which is what we had earlier earlier and then which what I've shown you earlier, and then this is the structure of our binary tree. You can see this. Our array 0 is 10 here, 10. Our array 1 is root left here, and our array 2 is root right here. And then after that is our array 3 is root left, and then go left again. Then after that is our root. Our array 4 is root left, after left then right. So this is the correct depiction of our binary tree here. After that, after getting the values, is we're going to the pre-order to order the numbers into their respective traverse binary tree. So first is pre-order. So this is a void. So we're calling a void here while getting the root value to set as our to set is as our set this as our root to check if our to check if it's gonna be correct. Okay, so we saw that the root that we have there is gonna be our temp here. Here, but the root here is gonna be our temp. It's gonna be our temp now. Okay, and then we're gonna check, and then first array is that we're gonna check if our temp is null. Since our 10 here, since our 10 here has a left and has a right, then it's not a null. After that, we're gonna print that here. Here is the printing method to display the numbers. So now, after printing that, and following the pattern here, which is root and then left and right, you can see that. So after following that, it's gonna be 10. So first, it's gonna be root, right? But since after checking that his left side, that it is still a root. You see this? It's still a root. And then it's null. Okay, no, it's not. It's not null. It's gonna check all the number, and then after going this 25 null, this is 25. The 25 is null. So go back to 15, and also the 30 is null because it doesn't have any more numbers. Then we're going back to 15, which is the root. So after that, then we're going back to 10. So after that, so our first number should be 10, and then left. So then we're going to left, temp left. But since R15 is still is not null, and 25, it's it's gonna be it's gonna perform this. It's gonna perform this again, and then it's gonna perform this again for another set. And it's gonna be 10, then 15, 10, 15, then left, then temp left. So going to left. But since the 25 is not null, and then we're going to print the left. Since this is 15 temp data, then we're gonna print the 25, which is the left first. We're gonna print the left. Okay, 25, and then after printing, we're gonna print the right, which is 30. After printing that, the temp will go check 25, and then we're gonna check 20. It's gonna check 20 now. Since 20 is null, never going back to the 10. So since 10 is not null, and our pattern is root, left, right, then it's gonna be root here. It's gonna be the whole left here. R1 set. It's gonna be a whole left here, and then it's gonna be our right. So this is pre-order. So after that, we're after displaying that, we should be seeing this pre-order and the displayed answer here like this: pre-order 10, 15, 25, 30, and 20. So now we're going to the in order. So after displaying the pre-order, we're going to in order, see out this in order, and then calculate calculate it. We're going to call again the void for in order in order this time. Where's in order? So here is the in order. Okay, now after jumping to that void, and our temp is gonna be our root, means that our pattern is left, root, and right. So it's gonna be left. So it's gonna type null. So since null, since 10 is not null, it's gonna it should print left. But since his left is still has still 25 and 30, it still can't print, and it's gonna go back here and then check again if it's null, and then after going back here to 15 here, and then it's gonna be left of 15 here, 15. So if the so that since 25 is null, because it doesn't have any more numbers to connect, it's gonna be it's gonna print. So pattern should be for in order, should be 25, and then after 25 there's gonna be a root which is 15, and after root is gonna be 30, r30. Okay, r30. Okay, good. And then after printing all the left side of this 10 here, after printing all the left side of this 10 here, then we're going back to print the root. We're about to print the root to follow this pattern. So it's gonna be 10. After printing the root, we're going to the pattern again and print the right. Since his right is null and doesn't have any more numbers, so we're gonna print that as it is 20. So this should be our in order. So our in order is 25, 15, 30, 10, and 20. So let's check. So 25, 15, 30, 10, and 20. So as you can see that it's correct. So now we are going, after displaying that, we're going now to the post order. Post order is here. We're jumping again to the void of post order while correcting the error. And then now we're going here now to the post order. So checking that here, let's put this here, post order. And then let's get this smaller so that it should fit. Okay, so now the pattern. So now that the pattern for our post order is left, right, root. So now, our root is 10, right? So our root is 10. Then it's gonna go left. But since he still can print 15 because it still has more numbers. It's it's going left again. It's going left again. This left. So our first number should be 25. And after getting 25, it's that we're going back to this root of 10, and then we're going left again. But since this 15 still has a set, then it's gonna, since we already print the left side, we need to print the right side here. It's gonna print the right side. So we're going to right side 30, which is 30. After printing his right side, we're going back again to the root. Then we're going back here. That since left is a set again, it's gonna check left. It's already printed, and then right, and then it's already printed, and then what's left is the root, which is 15. Then after dealing with this set, since all of the left side of our first root is printed, we're going to the right side of the root. So after going this, we're going to the right side, which is 20. But since 20 is alone and doesn't have a set, we're gonna print this at it is 20. So after printing that, the only number that left is 10, as it is the root. So it should be 10. So our post order should be 25, 30, 15, 20, and 10. Then it's gonna go back here and then print that. So here is error, then let's check it. So our post order is 20, 30, check, correct, 15, correct, 20, correct, and 10, correct. So after printing that, then the program's gonna end like here. So now that it ends, I will now discuss the rest of the program. So the rest of my program here is that the first choice here is the sorting, which is the bubble sort and the selection sort. Here it is. And the second choice is the binary tree, which is I've discussed. And the third choice is the info, my student name, the subject, and our course. And Our fourth choice is the exit function. Once you pick it, it's gonna exit. And then else, this else is for clearing, the CN. Is this for clearing the CMD? Because I put a loop loop in this I put a loop in this program that if you didn't pick within 1, 2, 3, and 4, it's gonna go back again. But if you pick any one of it, it's gonna become true. It's gonna become false. But if you pick any one of this, like this, it's gonna be false for the bool again. And then once it is false, it's not gonna loop again. It should end the program. And that's it. Thank you for listening. And let's show choice number 3, my name, and choice number 4. Thank you for using this blog. That's